Hello students, in yesterday's class we learnt what is meant by a polynomial and what is called a degree of a polynomial, then various types of the polynomial, that is the classification based on its degree. Then we saw what is the value of the polynomial at particular point k belongs to R. Then we also saw what is called a zero of the polynomial. When we call a value a real value as a zero of the polynomial, when we substitute that particular value in the place of x and we obtain the answer as 0, then we call that particular k as the zero of the polynomial. This is the main concept which we learnt yesterday. Then we saw an example to obtain the zero of the polynomial. We took up a quadratic polynomial, then we found the values at x equal to -1 and x equal to 2, for example, and at x equal to -1 we obtained the answer as 0. Therefore -1 is the zero of the polynomial p of x, and at x equal to 2 we obtained the answer as -6, which is not equal to 0. Therefore 2 is not the zero of the polynomial, it is just the value of the polynomial at the point 2. Next we saw the geometrical meaning of the zeros of a polynomial. We saw the graphical representation of the various polynomials, and we saw how geometrically we can relate or find the zeros of the given polynomial. First, for the linear polynomial, the graph will be always a straight line and it intersects the x-axis at only one point. Therefore, the number of zeros is 1. And for a quadratic polynomial, the graph is always a parabola, which is a open curve, open U-shaped curve. It can be open upward or open downward. And in this case, the graph of the polynomial will intersect the x-axis at most 2 points. At most 2 points. It is not necessary all the graph of the quadratic polynomial should always intersect at 2 points of the x-axis. It may or may not, but at most it can intersect only at 2 points, not more than 2 points. If it intersects at 2 points, it has two distinct zeros. If it intersects at only 1 point, then it means that it has two coincident points as 0, which means it has two equal zeros, the same point as zeros. It may, suppose in some cases it may not intersect at all. So in such cases we will call the quadratic polynomial does not have any zeros. But in general we can say it can have at most 2 zeros only. Then cubic polynomial. The graph of the cubic polynomial will intersect the x-axis at most 3 points only. At most. Maximum it can intersect only at 3 points, not more than 3 points. And in the similar case like quadratic, in cubic also, it is not necessary all the graph of the cubic polynomial should intersect the x-axis at 3 points. It may or may not, but maximum only 3. So there are possibilities for a cubic polynomial to have a single zero or 2 zeros or no zero or at maximum 3 zeros. So on seeing all these expressions, we can generalize that any nth degree polynomial can have at most n zeros only, maximum n zeros. So on looking at the degree of a polynomial, we can very well decide how many zeros that particular polynomial can have. So you may get questions like this in 1 mark. They may give a 5th degree or 6th degree polynomial and they may ask how many zeros does this polynomial can have at most. So you can say if it is a 6th degree polynomial, it can have at most 6 zeros. Hope you understood, right? Now in today's class we are going to see the relationship between zeros and coefficients of a polynomial. Last class we saw geometrically how we can obtain the zeros of a polynomial, right? So in today's class we are going to see algebraically or mathematically how we can obtain the zeros of the polynomial, right? And also we are going to see what is the relationship between the coefficients of the polynomial and the zeros. So to start with, we will take a linear polynomial. What is a general representation of a linear polynomial? As I discussed in the last class, general representation of a linear polynomial is ax plus b. This is the standard form of expressing a linear polynomial. Linear means degree 1. It should have a degree 1. A variable should have a degree 1. So we have written ax. A is the coefficient of x plus b is a constant term. So this is the general representation of a linear polynomial, ax plus b. Now we are going to see how we can obtain the zero of this linear polynomial. As we learnt yesterday, which value is called the zero of the polynomial? When the value of the entire polynomial becomes 0, then that particular value of x is called the zero of the polynomial. So we are going to obtain the value of x by equating the entire polynomial to 0. Why are we equating to 0? Because the definition of the zero of the polynomial says at which value the entire polynomial becomes 0 is called the zero of the polynomial, right? Hope you remember. So we are equating the entire polynomial to 0. So if we equate to 0, what happens? Now I am going to bring this plus b to the other side. If I bring this plus b to the other side, what will happen? It will become minus b, right? Now we need the value of x. So bring this a to the other side. So it will become minus b by a. So at the value minus b by a, the entire polynomial turns 0. Hence, 0 of the linear polynomial is nothing but minus b by a. What is minus b here? Minus b here is nothing but the constant term. So minus constant term divided by coefficient of x will give you the zero of the given linear polynomial. Let us see one example. For example, take one a linear polynomial. Shall we take 6x minus 4? This is a linear polynomial, right? Now how we can obtain the zero of this polynomial? We can easily obtain by equating it to 0. So let p of x is equals to 6x minus 4. So if we equate it to 0, what will happen? This implies 6x equals to 4. So x is equals to 4 by 6. So if I cancel this, this will become 2 2s are 2 3s are. So x is equals to 2 by 3. So the solution or zero of the given polynomial 6x minus 4 is 2 by 3. So using this formula, how you can obtain the zero of the polynomial? This formula says you can obtain the zero of the polynomial simply by putting negative sign and writing the constant term divided by the coefficient of x, right? So here shall we try? So here x is equals to, for every problem, every polynomial you should put negative sign. So I am putting negative sign now. Then b is nothing but the constant term. Here which is the constant term? Minus 4. Always you should take the values along with the sign, because the general representation we have plus sign only, but in the question we have minus. So take the value of b along with the sign. So now the value of b here is minus 4 divided by the value of a. A is nothing but the coefficient of x. What is the coefficient of x here? 6. So denominator you will get 6. So minus into minus it will become plus 4 divided by 6. So again if you cancel it, it will become 2 by 3. So we obtained the same value here. Yes? Hope you understood. So what is the formula to find the zero of a linear polynomial? Minus b by a. What is b? B is the constant term in the polynomial and a is the coefficient of x. So this is what the relationship between the zeros and the coefficients of a polynomial. So how we can obtain the zero of a linear polynomial? By directly writing the negative of the constant term divided by the coefficient of x term, and this is only for the linear polynomial. Next we are going to see how we can obtain the zeros, or what is the relationship between the zeros and the coefficients of a quadratic polynomial. Now let us see a quadratic polynomial. What is a general representation of a quadratic polynomial? Ax square plus bx plus c. What is A? A is a coefficient of x square, b is a coefficient of x, and c is the constant term. Quadratic means degree 2. So we have started with the second degree term, and then degree 1 term, and then a constant term. So this is a general representation of a quadratic polynomial. Now let us see how we can arrive at a zero of the quadratic polynomial with an example. Now we have taken an example. See, x square plus 7x plus 10. This is a quadratic polynomial. Hope you all have learnt how to obtain the solution, how to factorize the quadratic polynomial using splitting the middle term in your last class, previous class, 9th standard, 8th standard and all. We have solved many problems. Yes or no? So let us solve this problem. That is, let us factorize this problem using splitting the middle term. How we can split? First we need to multiply the coefficient of x square. First we need to multiply the coefficient of x square with the constant term. So what we will get? 10. Now we have to find two numbers in such a way that if you multiply you should get 10, if you add or subtract you should get 7. So which are all the possibilities? What numbers? 2 5s are, right? 2 5s are 10. Since last term is plus and the middle term is plus, no worries, everything will be plus only. Now how you will write? X square plus, instead of 7x we will write 2x plus 5x plus 10, right? Now take the first two terms and the last two terms, take common out. X is common, so we will get x plus 2, plus 5 common, so we will get x plus 5 2s are 10, so you will get 2. Again x plus 2 is common here, so we will get x plus 5. Now we factorized the given quadratic polynomial as x plus 2 into x plus 5. Now how to obtain the zero of the polynomial? As we learnt earlier, we need to equate the given polynomial to 0, because the definition of the zero of the polynomial says the value of the polynomial should be 0 at that particular value. Then only that value is called the zero of the polynomial. So what we are going to do? We are going to equate this to 0 to obtain the zero of the polynomial. Since this is product of two terms, when the product of two terms will be equal to 0? When either of them should be 0. So equate x plus 2 equal to 0, which implies x is equals to minus 2. Similarly, equate x plus 5 equal to 0, we will get x is equal to minus 5. So at x equal to minus 2 and x equal to minus 5. So at minus 2 and minus 5 only, the value of the given quadratic polynomial becomes 0. Hence, minus 2 and minus 5 are the zeros of the polynomial x square plus 7x plus 10. Or x equal to minus 2 and minus 5 are the solutions of the polynomial x square plus 7x plus 10. Right? Hope you understood. Now let us see what is the relationship between these zeros and the coefficients of this polynomial. Yes. Now let us see what is the relationship between the zeros and the coefficients of the polynomial. What are the zeros we obtained in the example? Minus 2 and minus 5. Let us see what we are going to obtain if we add the zeros, sum of the zeros. Let us add and see. Minus 2 plus minus 5. We are going to add both the zeros, which is equal to minus 2 plus into minus is minus. So minus 2 minus 5 is minus 7, right? And similarly we will see what happens if we find the product of the zeros. Product means what? Multiplication. So minus 2 into minus 5. Minus into minus will become plus. 5 2s are 10. Now let us see what is the relationship between this sum of the zeros and the product of the zeros with the coefficients, right? So if you analyze this, this is nothing but minus coefficient of x divided by coefficient of x square, and this is nothing but constant term divided by coefficient of x square. Let us analyze what is this coefficient of x in the given polynomial, which is nothing but 7, right? Before we have minus, so this is equals to, already we have minus, so minus coefficient of x in the given polynomial is 7 divided by coefficient of x square is 1. So minus 7 by 1, which is nothing but minus 7, which is same as the answer what we obtained. Similarly here, what is the constant term in the given polynomial? 10 divided by, what is the coefficient of x square? Coefficient of x square is 1. So we obtained the answer as 10. So which is same as the answer what we obtained after multiplying the given zeros. So this is what the relationship between the zeros and the coefficients of a quadratic polynomial. What is the relationship? If we add both the zeros, which is nothing but minus coefficient of x divided by coefficient of x square. If we multiply both the zeros, which is nothing but the constant term divided by the coefficient of x square. As we know, math is full of symbols. We don't like, mathematicians don't like in writing and writing, right? So let us see how we can denote this using symbols, right? So the zeros are denoted by alpha and beta. How we will call this? Alpha, and this is beta. These two are Greek letters. We will use it in math for representation or denotion, right? So we are going to denote the zeros of a quadratic polynomial by alpha and beta. So listen, we denoted zeros as alpha and beta. Now sum of zeros means alpha plus beta, which is nothing but minus coefficient of x divided by coefficient of x square, which is nothing but minus b by a. From where we got this minus b by a? Because the general representation of a quadratic polynomial is what? Ax square plus bx plus c, right? So here what is the coefficient of x, which is nothing but b. What is the coefficient of x square? A. So that's how we got minus b by a. And what is product of zeros? Product of zeros means we are multiplying two zeros. Zeros are represented by alpha and beta, so we have written alpha beta. Alpha beta we got by constant term divided by coefficient of x square, which is the constant term c. So c by a. So what is alpha plus beta? Alpha plus beta is minus b by a. Alpha beta is c by a. You should remember. Using this only we are going to solve the problems. So before that we saw how we can obtain the zero of the polynomial for a linear polynomial. For a linear polynomial, the zeros can be obtained by minus b by a, because linear polynomial can have only at most only one zero, which is obtained by minus b by a, which is constant term divided by coefficient of x, minus b by a. For a quadratic polynomial, the sum of the zeros, see here directly we obtained the zero for a linear polynomial using this relationship. But for quadratic polynomial, using these two relationships, we are obtaining the sum of the zeros and product of the zeros only. Using this, we will solve and find the zeros. Right? This you will understand while solving the problems. Now let us see how to frame the quadratic polynomial using the zeros. Now we saw if a quadratic polynomial is given, how we can obtain the zeros. Now we are going to see if the zeros are given, how we can frame the quadratic polynomial. It is very easy, which is nothing but x square minus sum of the roots into x plus product of the roots. That is x square minus alpha plus beta into x plus alpha beta. This negatives and all you should not forget, because casually we will put plus. Here also we have minus b by a and this is c by a. One is negative and the other one is positive. Since we have negative here, in the while framing the polynomial also you should put negative. X square minus alpha plus beta into x plus alpha beta. Let us check out for the same example what we obtained there. X square sum of the minus, sum of the roots what we got? Sum of the roots we got it as minus 7, right? So minus of minus 7x plus product of the roots we got it as 10. So plus 10. So this is nothing but x square minus into minus, it will become plus 7x plus 10. Thus we obtained the original quadratic polynomial. Hope you understood, right? So how to frame the quadratic polynomial using the zeros? X square minus sum of the roots into x plus product of the roots. So you should not forget, in today's class we have learnt what is the relationship between the zeros and the coefficients of the polynomial. For a linear polynomial, the zero can be obtained directly because it has only one zero, and the formula is minus b by a. B is nothing but the coefficient of x and a is the constant term. The representation or the values of a and b will differ from linear to polynomial, because linear we have only x term. In quadratic we have x square, x and constant term. So don't get confused with a and b representation of linear and quadratic polynomial, right? And for the quadratic polynomial, we cannot find directly the zeros, whereas we can find the sum of zeros and product of zeros. And the zeros are represented by alpha and beta. Sum of zeros is minus b by a and product of 0 is c by a. Minus b by a minus coefficient of x divided by coefficient of x square, and this is constant term divided by coefficient of x square. How to frame the quadratic polynomial? X square minus sum of the roots into x plus product of the roots. Now let us see exercise 2.2. Here the first question is find the zeros and verify the relationship. As we did one example, the same procedure. They have given a quadratic polynomial x square minus 2x minus 8. This is a quadratic polynomial, so they asked you to find the zeros. How we can find the zeros? By splitting the middle term. How you will split the middle term? Multiply the coefficient of x square with the constant term. So you will get minus 8. Now try to find two values in such a way, if you multiply you should get minus 8, if you add or subtract you should get minus 2. So what are all the possibilities? 4 2s are, right? So 4 2s are 8. But what about the sign? The last number sign is minus, so it should have 1 plus and 1 minus. How you will decide? Decide on looking at the middle term. Middle term is minus, so give greater number minus sign, or logically if you are good in thinking, think and put the sign, okay? So minus 4 into plus 2, so you will get minus 8 if you multiply, plus into minus minus, so 4 2s are 8. If you add or subtract, greater number sign is minus, so if you subtract 4 minus 2 you will get 2, and the greater number sign is minus, so you will put minus 2, so you will obtain the middle term. So instead of this middle term, what we will do, we will write these two terms. So this will become x square minus 4x plus 2x and the last term minus 8. Now take the first two terms and the last two terms. So x is common here, so you will get x minus 4 plus 2 is common here, so you will get again x minus 4. Since we have taken 2 as common, if you divide 8 by 2 you will get 4. Again we have x minus 4 as common, so we are left with x plus 2, right? Now from this step how we can obtain the zeros? Equated to 0. So x minus 4 equal to 0, so we will get x is equal to 4. If I bring this minus 4 to the other side, it will become plus 4. Similarly here x plus 2 equal to 0, so if you bring this plus 2 to the other side, it will become minus 2. Therefore the zeros are 4 and minus 2. So alpha is 4, beta is minus 2. Thus we obtained the zeros of the polynomial. But in the question they asked you to verify the relationship also. Verify the relationship between the zeros and the coefficients. So what is the relationship between sum of the zeros and the coefficient? Alpha plus beta is minus b by a and alpha beta is c by a. So before verifying, first let us list out what is a, b, c. What is a? A is coefficient of x square, which is 1. B is coefficient of x, which is minus 2. And c is constant term, which is minus 8. Remember, always you should take along with the sign. Whatever sign, if it is negative sign, you should be very careful. You should take along with the sign. Now just we will substitute in alpha plus beta and alpha beta, and we will see whether are we getting the satisfying the relationship. So first we will find what is alpha plus beta. What is alpha plus beta? The value of alpha is 4, the value of beta is minus 2. So 4 plus of minus 2. So which is equals to 4 minus 2, which is 2, right? And here alpha beta is 4 into minus 2, which is equals to 4 2s are 8. Now alpha beta is nothing but c by a, right? So we will find what value are we getting when we find c by a. C value is minus 8 and a value is 1. So minus 8 by 1 is nothing but minus 8. So we got alpha beta is same as c by a. Similarly here alpha plus beta is nothing but minus b by a. What is minus b value? Already one minus here, so put minus of the value of b is minus 2 divided by the value of a is 1. So minus into minus plus, right? So 2 by 1, which is nothing but 2. So we obtained alpha plus beta the same as minus b by a. Thus we verified the relationship between the zeros and the coefficients of the polynomial. This is how we need to solve this problem. Let us see the second question in the exercise. They have given you the sum and the product of its zeros, and they asked you to find a quadratic polynomial. Sum and the product means what? Alpha plus beta is sum. Alpha plus beta is 1 by 4 and the product alpha beta is minus 1. They asked you to find the quadratic polynomial. That also I told you how to find, right? So how to frame your quadratic polynomial? X square minus sum of the roots into x plus product of the roots, right? So if you simply substitute these values, you will obtain the quadratic polynomial. X square minus sum of the roots in the given question is 1 by 4 into x plus alpha beta is minus 1. So x square minus x by 4 or 1 by 4 into x minus 1 is the quadratic polynomial. It is enough if you leave the problem as such. You don't want to take LCM and all. So the answer is x square minus x by 4 minus 1. Hope you understood. So based on these two methods, try solving exercise 2.2 question number 1, subdivision 2, 3 and 6 as homework, and second question subdivision 4, 5, 6 as homework. Try solving these problems as homework. I repeat, exercise 2.2, first question 2, 3 and 6, second question 4, 5 and 6. I have written wrongly. 4, 5 and 6. Solve these problems, and if you have any doubt, contact me. We will see the remaining problems in the next class. Thank you, students.